I am going to take you back to this question that we did a few days ago. I think Friday, actually. Yeah, Friday. Where we're looking at a parabolic opening for a tunnel, right? You've seen tunnels that trains go through or even traffic goes through. A lot of them do have that parabolic shape to them. So this one does. That's not a great parabola, but use your imagination. For much of the drawings that I do, you really need to use your imagination quite a bit. So, has a parabolic shape. It's 24 meters wide. So I'm just going over the question, the third part we did already. It's 24 meters wide, so it goes from here to here, 24 meters apart. And at 3 meters from one edge, it goes 6 meters up. So what that told us is that if we put this on a Cartesian grid, that we could put one of the points for where it hits the road as 0, 0, and the other point would be at 24, 0. That's what we said. We also said that a third point would be 3 meters from the edge, 6 meters up, which is a 0.36. So we used all of that information to come up with an equation, put it in factor form like we just did a while ago. Right? Let me scroll down here. Ended up with the equation minus 2 over 21x x minus 24. Again, I'm just reviewing. And we wanted the max height, so I think might have been AJ who said it, or somebody in the back there said that it was in the middle between the two zeros. So we said that must be a 12. We plugged 12 in and we got 288 over 21. So the maximum height was 288 over 21. Now I put this on a Desmos graph. Let me delete this page here. Delete that page as well. Here's a Desmos graph that I put together. I used the exact equation that we came up with, threw it into Desmos, and lo and behold, it matches exactly the way we want it to be. 24 meters along the ground from 0, 0 to 24, 0. It goes through those 2 points. So that's where the tunnel hits the ground. 3 meters from the edge of the tunnel, it's 6 meters high, perfect. Our vertex is at 12. And even though it's not showing you as 288 or whatever it was over whatever it was, that's what I put into Desmos, and that's where the vertex is. So that's what we've done so far. Now, we're going to continue this question. We're going to ask something else. And let's hear your thoughts on this, right? I don't want to be the one talking all the time. Let's say this was the challenge question. You saw this on the test, on the assignment test on Wednesday, and you're trying to figure out how to do this. To the nearest meter, what's the maximum height of a 12-meter wide truck that can pass through the tunnel? Say it again. To the nearest meter, what's the maximum height of a 12-meter wide truck? So this truck is 12 meters wide. And this truck has to get through the tunnel without scraping its sides or butting up against the edge of the tunnel. So we're trying to figure out how tall can this truck be? Can this truck be any height we want it to be? Clearly not. There's a limit here. And I'm saying the equation of the function can help us to find what that limit is. Can anybody suggest how we could determine where the maximum height would be? We're listening over here or we texting? What are we doing? I mean, let's just focus on this here. All right. What is the maximum height? The truck has to be 12. So think of the truck. Remember, it's 24 meters from one edge to the other. That's great. The truck is 12 meters though. How high can it go? Any thoughts on how we can figure that out? Yes. If we substitute 12 for y, which we just did a few minutes ago, we'd get the vertex of the function, which would mean that you're thinking that the truck can go all the way up to 13 meters high. But that wouldn't work. I don't think that would work. Right? If the truck was 12 meters high, we'd have to get that truck to be a single line to go through the tunnel. Well, that's kind of what Nakib was suggesting. Nakib, it was Nakib, right? Nakib was suggesting. Putting in 12, though, only gives us what the coordinates are at 12. 12 is at 13.714. But if you had a truck that was this high and 12 meters wide, could it go through this tunnel? I don't think so. I don't think so at all. Unless the truck was just one single line at 12 meters, then yeah, it could go through. But we need to make the truck 12 meters wide. This way. Okay. All right. So, Chi, what do you want to tell us? Okay. I like that idea. Here's what I think Suchir is saying. If we need to make the truck 12 meters wide, first of all, the truck needs to go through the center. Okay? There's no point putting the truck over to one side or the other side. If you want to get maximum clearance, let's put the truck in the center, right? So if we center this thing, right? Now the center of the thing is at 12 right here. We agreed on that a few minutes ago. Let's go 6 meters this way. That would be up to 18. And 6 meters this way, that would be up to 6. Can we agree on that, first of all? From the 12-meter center line, let's center this truck. Hashim, are we listening back there? Because you still look like you're distracted to me, right? You got to stick with this, all right? You can check your phone later, all right? So from that center line at 12, so the 12 does come into it, we need to stick the truck, we need to extend the truck 6 meters in both directions. That's what you're saying, right? So if we get the truck to go 6 meters this way and 6, isn't this going to therefore be 12 meters from here to here, from 6 to 18? Doesn't that make sense that we now have a 12-meter wide distance from one edge to the other? So what do we do now that we know where to center the truck? Truck has to go 6 to 18, right? So the truck has, and I'm going to give you a clue when I put this in here. The truck has to be from here to here. That's all of this distance here. This is truck right there. All of that's truck. Yes. There you go. There you go. We need to see what the truck on this line would be. Well, first of all, let's go all the way up, see where that goes up to. Now, I have a diagram which is giving you the answer, okay? Well, what if we didn't have the diagram? Then what would we do in that case? Can we not use the equation that we had? Do we have an equation for this line? Yes? What an equation, right? Let's use the equation. What do we do? Let me write the equation for you again. Take you back to the line before this. The equation of the line was minus 2 over 21 x minus 24. So y equals minus 2 over 21 x minus 24. How do we use the equation? What do we put into the equation to make that magic happen? And at the end of it, it says to the nearest meter. So we have to figure out what to round it to. So what do we put in the equation? That's the question, right? And where do we put it? Do we put it for the x or do we put it for the y? Any thoughts? Help me out here. Yes, Shreyash. You see, putting in 12 is what we've been saying, though, Shreyash. Putting in 12 tells us how high it is in the middle. What we really need to know is how high it is at 6 meters or at 18 meters. That's the height that we're trying to figure out here. Okay, yes, Gary. And in fact, both should give us the same answer. If we center the truck, that should be the same answer. Does that make sense to you? Okay. So we're going to do exactly that right now. So y equals minus 2 over 21 times, we'll use 6, right? I'm saying that both should give us the same thing. And 6 minus 24. Okay. Minus 2 over 21 times, I put 6 over 1 times. This looks like minus, I'm going to say 18 over 1. I think I'm right. Okay. If I'm wrong, you let me know. Yeah, I think I'm right. So I need you now, with your calculators, to tell me what that number is. And then we're going to talk about how we round it. You can give me a decimal, that's fine. We're going to talk about how we're going to round that number. Right? So grab your calculator. Minus 2 over 21. I can't do this in my head, not even if I tried. Or maybe I could actually. Maybe I could reduce it down and get something not too bad. Uh, no, I'm not going to try. You give me an answer on your calculators. You have an answer for me? Anybody have an answer for me yet? Anybody? Anybody? Go. Yes. Whoa, I'm thinking if I multiply negative by negative, I should get something positive. Yeah, everything is being multiplied, right? It's three things being multiplied. Minus 2 over 21 times 6 minus 24. So I should be multiplying. So help me out. Yes, go ahead, please. Sorry, Sana, say it again. 72 over 7, thank you. And that works out to be approximately what? Give me a decimal number. 10.28? Okay, thank you. So we have to make a decision now, right? What would be an appropriate answer if the question said to the nearest meter? Do I round it up or do I round it down? Don't think about rounding rules now. Just think about the truck trying to pass through this thing. Round it up or round it down? Yes. Even if it was, and you're going to say round it down as well? What were you going to say? So you had your hand up. You're going to round it up? It's interesting. I'm gonna write both answers down and we're gonna see which one makes more sense. So is it gonna be 10 or 11 meters? Are you rounding up or rounding down? Now I don't want you to think so much about rounding rules. I want to think about what makes sense for this question. I think when you look at the graph, it will kind of tell you. Now it's very clear from the picture that it is 10 point something, right? Can you see that from the graph, right? Okay. Now, if I went up to 11, what's going to happen? If I went up to 11, yes. This truck is not going anywhere, okay? This truck is stuck. This truck, it can't even enter the tunnel, to be honest with you. This truck will not get through this tunnel because if you go to 6, plug that in, 10 will work because 10 is under the line. You want the truck to be under the line, don't you? Isn't that where the bridge is? And you want it to be under the bridge, not over the bridge. Over the bridge makes no sense. Okay? Does that make sense to you, what I just said? So, the answer I'm looking for in this case is 10 meters. Will a 10-meter truck, 10-meter high truck fit? Absolutely. Let me come down. Therefore, a 10-meter high truck can fit in the tunnel. Could it be less than 10? Of course it could be less than 10. The lower it is, the better, right? Because anything lower than 10 still fits through the tunnel. Anything higher than, if you go to all to up to 11, no, you're not getting through, right? You could, if you wanted to really push it, you could make the truck even 10.2. Now, this is very close to 10.3. So you could make this 10.2 and it would get through, but almost scraping against the edge of the tunnel. So that's it for that question. All right, I'm going to move on now. I'm going to go to the second thing that we have on our agenda today, which is to complete the stuff that we have for this unit. And then we're going to go to the problem set questions after that. We're at 10:40. Unless anybody has any questions about this, I'm going to move on. Yes? First page. You mean the first page? Oh, this page here? Now remember that I'm recording this, so I should have, unless the recording fails, which is possible. We had a lot of I had a lot of failures, not you. I had a lot of failures on Friday. Then this should be on YouTube later. I have to edit it first, though. So this should be on YouTube later on. All right. I'm going to move along now, folks. I'm going to move along. So the second thing we have now is this. I'll save all of that. We're going to be talking about the point of intersection between a quadratic and a line. It's the last thing on this thing. And that's the learning goal. And the first thing we're going to do is do a bit of review. Back in grade 10, that's just 1 year ago for you, at various points you did math. I looked at the results of the survey. Back in grade 10, you learn how to solve a system of equations. A system is where you have more than one equation with more than one variable. And you're trying to figure out the x and the y that satisfies both, right? That is what you're looking for there. Let me just see if the thing is on. Yeah, that looks like it's on. Well, I really hope this works. We'll see. Now, does anybody remember how this substitution thing works? This is review, not doing anything new here, right? This is all stuff you should have learned in grade 10. We're not getting distracted by our phone here, right? All right, we're going to keep that thing in the pocket for now. Okay, does anybody remember how to solve the first one? We're not going to do both. We don't have time for both. Does anybody remember how to solve a linear system like the one that's up there by the substitution method? Anybody? Go ahead, please. Aria.
You have to rearrange one of the equations to
Mhm.
see if you want to find x or y first.
Nice. Hopefully, everybody heard what Aria just said. Try to isolate one of the variables from one of the equations. That's exactly what I'm about to do right now. So I'm going to go ahead. I'm only going to do the first one, remember I said, not the second one. We don't have time. So I'm going to take this equation. I'm going to isolate maybe the x from this equation, the top equation. We're going to try that. We could have isolated anything else, but let's just go with x from the first equation. So I'm going to say that 12 minus 4y is equal to 2x. Let me get rid of this line right here. Right? So I just took the 4y from the right and subtracted it from the left. Yes, absolutely. Absolutely. Just another way of interpreting it. And let me just do it this way now. Let me put the 2x first. 12 minus 4y. Now, what Arya said is we need to isolate either the x or the y. So I'm going to isolate the x by doing what? How can I get that x on its own at this point? Help me out, folks. Help me out. Yes, Jay. Divide both sides by 2. Sorry. Divide both sides by 2. So 2 here, 2 here. This leaves me with x equal, divide this by 2, which is 6. Divide that by 2, which is 2y. So that is my x value. That's what x is coming from equation number 1. What do we do with that? Where do we go with that? What do we tell me where we take that information? Charmaine, go ahead. The x, wherever x is in the second equation, we're going to put that is. Absolutely. Thank you, Charmaine. So, in this equation, we're going to say 3y, still have y there, plus 4 times this thing that x is, which is 6 minus 2y, is equal to 4. All right, see what we did? We just took this thing that x was and put it for x in the second equation. So 3y plus 4 times this thing that we said x is in the second equation. Okay, so 3y plus 24 minus 8y equals 4. The great thing now is that we only have y's in this equation. We can't solve an equation with two variables if it's just one equation. But if we have two equations, which we did, then we can make the two equations into one, which is what we're doing now. So 3y minus 8y is minus 5y plus 24 equals 4. Take the 24 from the right. This is just basic equation stuff now. Minus 5y is equal to 4 minus 24. So minus 5y is equal to minus 20, and y is equal to 4. We all know that that's only half the question, and that we have to do what else again if we want to get the full thing? Yes, sir. Correct. Put that y value back into one of the equations, doesn't matter which one, to get the corresponding Abel. Thank you, Abel. To get the corresponding x value. So we already had that x was equal to something. X was equal to 6 minus 2y, so 6 minus 2 times 4. So x is equal to 6 minus 8, which is equal to minus 2. So my solution is this. 4 minus 2. Right? That's my solution right there. That's the combination of x and y that works in both equations. Equation 1 and equation 2. Yes, Abel. That's it. Gary, sorry. Sorry, Gary. Yes, Gary. Oh, x is minus 2. Yeah, you're right. Thank you. Thank you. That's how you lose marks on a test. Yeah, the y is the 4 and the x is the minus 2. Absolutely. Thank you very much. All right, so that was just review. Grade 10 style review. So let's see how we can use that for what we're doing right now. I want you to think about a linear quadratic system. So what you just did was a linear system. It's just purely linear. Two linear functions, and you basically took them and figured out the point that was the intersection point between them. But what if one of the functions was quadratic and the other one was linear? Well, there are three possibilities that can come out of that. A system of equations involving lines and curves is called a linear quadratic system. A line can intersect probably one of three ways. There could be two intersection points. All right, so here's an example. I give you two equations. So 2x squared minus 5x minus 12, and the 3x minus 2. They have two intersection points right there, right there. And that's because my b squared minus 4ac is greater than 0. A couple of days ago, we talked about b squared minus for the discriminant being greater than 0, meaning you have two solutions. That's what's going on here. We have two solutions, right? 2 points of intersection, two places where the two lines cross each other. Somewhere here, somewhere there. So that's one possibility. Second possibility, that I change the equation now. So now it's minus 9x minus 4. And one is that this only touches at some one point. It's the same quadratic equation, but it only touches at one point this time, some point somewhere around here. I don't know exactly where, somewhere in there. We're going to solve it in a second. And that's because b squared minus 4ac is equal to 0. The value discriminant this time was 0, which we talked about before. That's when you have one solution. Then you can also have no solutions. That's where it takes us for this, the third one. That is to say that this line, and I use x minus 17, and this parabola never, ever meet. Right? They don't cross at any point. And that's because my b squared minus 4ac is negative. And that's what makes it no solutions. Okay, now let's get down to business here. Let's try a couple of examples. Determine the point of a point or points of intersection. Maybe say point or points, because it could be that it's more than one. Could be that it's only one, could be that it's none. Determine the point or points of intersection algebraically. Use the substitution method. So here's the good news. One of the equations, in fact, both of the equations already have isolated the y. So it's just y equals. So we're going to do the same thing we did, and in fact, the same thing you did on your homework, where you're going to make one equal the other. So 3x minus 2 is equal to 2x squared minus 5x minus 12. Just make them equal to each other. Hopefully that makes sense. Yes? With the, well, this is a parabola, the 2x squared minus, yeah, that's a parabola, absolutely. Remember that any function that has an x squared in it, and x squared is the highest power, is a parabola. So this one is a parabola. In fact, these are the same equations that were in those pictures I just showed you. All right, so 2x squared minus 5x minus 12 is equal to 2x squared, sorry, is equal to 3x minus 2. Set them equal to each other. Are we good so far? All right, perfect. So what do you think I'm going to do next? Where do you think I'm going to go next? Yes? Absolutely, because this looks a lot like the homework we just talked about. So we want to make, when we're trying to solve a quadratic, the goal is always to try to make everything equal to 0, right? So I'm going to take 2x squared minus 5x minus 12 and minus 3x plus 2 equals 0. Right? I took everything that was on this, well, I kind of flipped it around. I put this on the left-hand side, just to make sure that everybody's clear on this. I put this on the left-hand side. Then I took the 3x minus 2 and subtracted it. So minus 3x plus 2 equals 0. All right. So let's see what we got here. 2x squared minus 5x, so that's minus 8x. And then the minus 12 plus 2 is minus 10 equals 0. Okay. Hope I haven't lost anybody yet. Yes?
In the second line, where did you put the positive 2? At the end.
Okay. Because I took everything that was on the left-hand side and I subtracted it from the right side. So this 3x became minus 3x. That minus 2 became plus 2. Okay, thanks for the question. And I really appreciate getting those questions. You got to stick with us here, folks. All right? You get to go use a cell phone in about 10 minutes or 15 minutes, but not right now. All right? Are we good so far in the back here? Following along? All right. Yes, question? No? Okay. All right. So what do we do now? What's the next step in solving this? What do we do now? What's the program here? What's the solution? What do we do next? Help me out, folks. Help me out. I need to solve it. I don't know what x is yet. What do I do? What do I do? I want to see some new hands. I appreciate that. Thank you very much. What do folks in the front here feel? Folks on this side, what do you feel? What's the next step? How do I solve this? I need to solve for x. What's the x? Yes. AJ, what's that? How? Factor out the 2. I don't need to use magic x on this because it's a common factor of 2. So if I can factor out a common factor, I should. And what AJ is saying, that there's a common factor of 2. So x squared minus 4x minus 5 equals 0. And now I can factor the rest. Can Wanya give me those factors, please? Can you give me the factors that I need to make this magic happen? So plus 4 or minus 4, what are we talking about? Plus 4 and what? Plus 4 and negative 5. If I multiply those two numbers, I'm going to get minus 20. But I'm trying to get minus 5. So let's give her a chance. Let's give Wanya a chance. Two numbers that multiply to give us minus 5. When I add them up, I get minus 1. That's what I'm trying to do here. Thanks for offering. Let's just hear what Wanya has. Thanks, AJ. Let's just hear what Wanya has. Think of combinations of numbers that give you minus 5 when you multiply them. So this times this gives us minus 5. And the same two numbers, add them up, I get minus 4. That's my goal right now. That is my goal right now. Yes, go ahead. Minus 1 and 5. I'm going to write that down. So x minus 1 and x plus 5. Okay, let's test that out. When I multiply those two numbers, I get minus 5. Check that box. That's good. When I add them up, do I get minus 4? So how do we fix this? Because you're so close, but it's not quite right. So we get one box checked, but the other box is kind of off. We don't want positive 4, we want negative 4. So that's the trick to this. We don't want positive 4, we want negative 4. Following along here? Making sense? All right? Yes, go ahead. You will try that. So you're saying minus 5 and plus 1. So that plus here, and I'll erase this. So we'll check again. Multiply those two numbers, I get minus 5. Check that box. Minus 5 plus 1, is that minus 4? Minus 5 plus 1? Good. Okay, perfect. So what is this telling us now? What exactly did we just figure out? What did we just figure out, Sarah? What do we now know? Do we know the x values at this point? What are the x values? X is equal to negative. Remember the zero product law? I'll remind you what the zero product law says. If I'm multiplying these things and getting 0, either x plus 1 equals 0 or x minus 5 equals 0, this answer is x is equal to minus 1. This answer is x is equal to 5. But that's not the end of the story. Tell me where we need to go next. Yes, Abel. Yep. And I'm going to vote for the simpler one, which is y equals 3x minus 2, the linear function. So when x is minus 1, y is equal to 3 times minus 1 minus 2. When x is 5, y is equal to 3 times 5 minus 2. In this case, this is equal to minus 3 minus 2, which is minus 5. And this is 15 minus 2, which is 13. So here come finally my two solutions. So the solutions are, and Gar, I'm going to try to get the order right this time. The x of minus 1 gives us minus 5. And the x of 5 gives us 13. We can compare that to the actual graphs because I do have the graphs here. I'm going to go back. So minus 1, minus 5, and 5, 13. Minus 1, minus 5 is this font right here, and the other one is the right there. Right? So it kind of works. Not kind of works. It works. Yes. Sure. Sure can. But I'm just showing you that the graph agrees with our calculations. So minus 1, minus 5, and 5, 13. Okay. Yes. Okay. So let me go back and go that. And thanks again for the question. You're talking about up here, right? On this line? Down here? Oh, the equation, as I wrote the equation down wrong. The equation was 3x minus 2. So I'm just putting the x value back into that. Okay? I was worried that I might have got the equation wrong. Okay, folks, that's good. That's good. And let's try the second one. Right? The second case is where we're supposed to have one solution. Now, this is a case where b squared minus 4ac is going to be positive. Right? That's why we have two solutions. Now, the second one is this one, minus 9x minus 4. So we're going to do exactly the same thing again, which is set them equal to each other. Okay, nothing different here. So 2x squared minus 5x minus 12 is equal to minus 9x minus 14. Same thing, right? The two y's, if the two y's are equal to something, then the two things have to be equal to themselves. All right? And if you remember what we did the last time, we need to put everything over, as somebody suggested the last time, onto one side and set it equal to 0. So that would be 2x squared minus 5x minus 12 plus 9x plus 14 equals 0. Okay, just shifting all of this stuff here over to the right. Obviously, you have to change signs. Okay, so let's tidy this up. So that's 2x squared, the minus 5x and the plus 9x. That sounds to me like 4x. And the minus 12 and the plus 14, that sounds to me like plus 2 equals 0. Let me double check that. Minus 5 plus, yeah, that's 4, and minus 12, yeah, that's plus 2. Now, remember what AJ said the last time? Factor out the common factor. All right? So, Anjali, what's that common factor this time? Sorry? 2. So if I factor that out, what am I left with, Anjali? Mm-hmm. That's another 2, yeah. Sorry? Plus 1, yeah, good. Yeah, folks, I'm very much aware of the fact that I don't write very well. So I apologize for that. All right, let's keep going. Can this be factored? All right, the last time we were able to factor, go ahead, please. It is a perfect square. So it's something squared. What is it? What is it squared? X plus 1 squared equals 0. So it really means that I only have, this is a case where b squared minus 4ac is going to be equal to 0. So I really only have one solution. X equals minus 1. That's the only solution in this case. There is only one POI, point of intersection. I can go ahead now and I can plug this into my y function to get my corresponding y value. So y is equal to minus 9 times minus 1 minus 14. So that's equal to 9 minus 14, which in my world is minus 5. Okay? So it looks like my POI is at minus 1 minus 5. Solution, or POI. I put it POI in brackets. Minus 1 minus 5. Let's go back and look at the graph again. Make sure, I'll come back to this page in a second. Here's the graph. Oh, no, that's not it. Here's a graph right here. No, it's right here. Minus 1 minus 5. Looks like it's that point right there. Minus 1 minus 5. Right? It's not the clearest graph in the world, but it kind of looks like it is. So there's your POI right there. Right? One place where it cuts through the x-axis. Not through the x-axis, where the two lines meet. Sorry, I'm saying it wrong. Where the two lines meet. Okay. Abdullah, how are we doing so far? We doing okay over here? Okay, good. Yes. Sure can. Okay. All right. Let's see if we can get through this last case, which is where we expect there is no point of intersection. We'll see how that looks. So here's the third one, y equals 2x squared. So I'm going to set them equal to each other. We're going to go through the same steps again. 2x squared minus 5x minus 12 equals x minus 17. Just set them equal to each other. Okay. And then we're going to say, okay, bring everything out to the left side. We're not doing anything new here. 2x squared minus 5x plus x. No, not plus x. That's not right. Minus x. And then, why am I putting it out? No, let me do it the way I've always done it. Let me go back. Let me stop here. I want to be consistent. Minus 5x minus 12, and then minus x plus 17 equals 0. So again, I just changed the signs of those two sides and put them on the left side. Okay, so 2x squared minus 5 minus x is minus 6x. Minus 12 plus 17 is plus 5 equals 0. So for the first time, it doesn't look like we can factor it. Not easily, anyway. Can it be factored at all? I don't know. What's the test again to see whether we have solutions? What's that test that we have been talking about, that I have been mentioning? Yes, Gary? Discriminant, b squared minus 4ac. Because if it fails that test, where the answer is negative, we just abandon ship at this point. We're not getting anywhere with this. Right? There is no way to factor it. There's no way even to use a quadratic function for this if b squared minus 4ac is negative. So let's find out. A is 2, b is equal to minus 6, and c is equal to 5. Okay? So we're not going through the whole equation. We're just doing the discriminant. So discriminant, which I hope I'm spelling right, discriminant would be minus 6 squared, that's your b squared, minus 4 times 2 times 5. Now, I've always encouraged you to try to do things mentally. That's 36. If 5 times 2 is 10 times minus 2, that's minus 40. All right, you can put that on your calculator if you think you need to. And this is minus 4. Conclusion? There is no POI. Okay, these two lines are not going to meet. Yes.
What's the formula that you used?
The b squared minus 4 is the discriminant. I'll put that on the side. I'll put that. Okay, tell you what I'll do. Let me put this thing to charge for a few minutes. My stylus needs to be charged up every once in a while. So I'll write the discriminant formula, which is the b squared minus 4ac, right here. Okay? No, I'm not going to start it now. I'm going to stop the recording as a matter of fact, and I'll just test it out and see if it's working. What we're going to, in fact, I'm going to stop it right now.